Hey everyone, I'm Alex Dunn. We're going to talk about a whole bunch of stuff today, actually, namely around accessibility, AI, cloud development, assistive tech, gaming, of course. So I'm assuming those of you who are here, some sort of interest in one or more of those. How many of you are gamers, play video games? Nice. Okay, just about everyone. How many of you are into accessibility tech? Nice, nice. How many are like, show me the AI, show me the cloud development, or .NET? Right, you saw the rest of that. Cool, cool, cool. So before we get into it, like I said, I'm Alex Dunn, but on the internet I'm Swab Pirate because Alex Dunn is a very ordinary name, and I tried to use it online, and then no one found me. I mostly work in sort of the Microsoft tech sort of stack, .NET, Azure, AI, a lot more Python, IoT stuff. And there's more than one Alex Dunn in the dev team at Microsoft. So if you're like, oh, the Alex Dunn who does Microsoft related things, it's a little bit harder. So I'm Swab Pirate. I'm a Microsoft MVP, Bixby Premier Developer, AWS subject matter expert on Alexa, and a PubConf champion because I tell funny jokes while giving talks. But today, like I mentioned, we talk about accessibility in gaming. And really the title I want to use, but it never fits on these RFPs, is real world applications of AI, cloud application development, using .NET, IoT, a little bit of Python towards the end, and it's all in sort of story format with video games and lots of great demos and stuff like that. So warning ahead of time, there's video game violence in this talk. If you're not cool with that, it's going to be basically sprinkled throughout. I would definitely say avert your eyes because it's mostly fantasy and first-person shooter type of stuff, but it is sort of sprinkled in throughout in the demos. So how many of you know what this screen is, have seen this in your life? Okay, so someone may have played Dark Souls before. If you don't know, this is the title screen of Dark Souls, and really this is the screen you see the most in Dark Souls. It's sort of noted as the hardest game series that's out there, and it's my favorite game series. I play with my friends. I'm the kind of person who goes and does challenge runs. We do drinking games when we play. If you die, you drink, and then we all just fall asleep at the end of the night. But one of the things I sort of realized when I started playing this game more seriously is it is probably the least accessible thing that's out there. And so I have a brother, he's about 15 years younger than me. He lives with autism and a few different physical disabilities. And I was playing Minecraft with him one day and sort of came to the realization, like, he's not going to be able to play a game like this. And it's not because he doesn't have the reaction time. It's not that he doesn't have the patience to sort of put into it to learn every person's move and get through the level one by one. But it's because the actual number of actions you have to take on a tiny, tiny little controller is almost impossible for him. So I started to sort of explore new concepts to be able to make Dark Souls a game that he could play. Ideally with me, with my friends, with the rest of my family as well, my other brothers and sister. And so my first thought was like, well, what if I could make a game that could help play Dark Souls for me and then introduce it to my brother? And that sort of started as a pretty wild concept. Kind of sounds like cheating in most video games. And there's a few cases where we built stuff that is basically cheating. But my goal was to get to something that actually worked, that I could hand him and let him use to play a game. And I'm going to share a couple different failures along the way in terms of how we go from this sort of wild concept to working software and eventually to a real product that's helping people now. So a couple rules: no hacks or mods. You can't change the game code. We can't run this against a modded version of Dark Souls. It should just work out of the box. It has to be able to kind of work with other games, at least be extendable. It doesn't have to be just a Dark Souls thing, but we could start there. It can't just be used by me. That kind of defeats the purpose, and it has to actually work. First thing I started with was image recognition. How many of you have done custom computer vision models or something like that in the past? If not, totally fine. We're not even going to show you how. We're just going to talk more high level about it. Essentially what you do is you take different frames of images and you do object recognition training where you label things like, hey, this little thing here, there's a big scary sword, and this is our cool guy. And our goal is to be able to say, big scary sword is coming towards our cool guy. We should do something. We should dodge. We should run away. They're not attacking us. Maybe it's our chance to attack back, and try to automate that a little bit. So I meticulously went through an entire first section of Dark Souls in multiple playthroughs and went, frame, label, that's a sword, that's a bad guy. This would be a good time to dodge. This is our guy. This is our guy with this armor. Spent hours and hours and hours building this gigantic computer vision model that I would then run on my same PC that I was playing the game on to be able to detect each frame of my actual desktop screen and then basically try to do USB inputs. And what I've come to learn is that it's a hard game intentionally. You are always in danger. You are under attack at all times. And when I tried to run it, my guy was basically just like flailing and rolling and just being like, panic, 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 which is kind of how you feel when you play the game anyway, but it was really interesting to see that sort of metamorphosized. I also burned through a graphics card trying to actually run the model to detect those evil punching mushrooms from the previous screen. Okay, so that's not going to work. Plus, if it's going to work for other games, that first rule, I can't go in every single video game and like label custom things over and over and over again. So I was like, okay, well, what else can we do? Every RPG game has a sort of boss music, a combat music. You're in danger, we're going to play scary music. Let's start using that to react. Basically, scary music, throw in some random dodges every now and then to kind of help you out a little bit. A little bit less cheating, because the other one was like we basically built a bot that could do it for you. And you know, basically that doesn't work because it's just sort of spastic again. It's less aggressive. There isn't a giant model. I didn't burn through another graphics card, but it was pretty useless. One of my other favorite games to play with my friends and with my family is Call of Duty. Anyone here first-person shooters, Call of Duty fans? Right? Like to shoot up the bad guys? Cool. We got great videos of that. I have a temper problem when I play online first-person shooters and rage whenever something doesn't go my way. And so I was playing with my friends one day, and they knew about the project and what I was sort of trying to do. And they're like, well, what if like when you're yelling at it and saying like, dodge, go, serpentine, serpentine, it would actually work? And I was like, oh, that's an interesting concept. You know, I work in voice AI, sort of my day job. I'm sure I could get to the point where I can yell and have my guy Will Ferrell in Land of the Lost and run away in a sort of serpentine pattern. We can get there. Okay, let's try this. The only things I really need are voice input. I need to do speech recognition to be able to know if I say serpentine, we need to start taking actions. I wanted to do this with a tool that a lot of people had. So I wanted to use an existing smart speaker or smart assistant like Alexa, Google Assistant, Siri, or Bixby to start, but then sort of grow it beyond that. So in order to do that, I needed to be able to route the request over the network from that device that you're speaking to into the actual device that you're playing the game on. And therefore, I needed to receive the events on that client machine, on the PC that I'm playing on. So this is what it looked like. User talks to a device like a smart speaker, Alexa, Google Assistant, whatever. That request goes through the voice assistant service. So you would build an Alexa skill or a Google action that would say if the user said jump, hit the space bar. It would then send that to our custom API where we're hosting the logic. And then I'm using SignalR to send that request down to another app running on the Windows machine that would then basically try to do the input using a whole bunch of different ways to do like simulated inputs and stuff like that. So the goal is to be able to say something like, Alexa, tell the Call of Duty controller to shoot, and have it actually go, boom, shoot. Pretty cool. Here's what that basically looked like in .NET. This is on the actual API side. So I've got this function in my controller, this method on my controller, that's handling a request from Alexa. It's the first assistant I wanted to use in this use case. Essentially, we take that request, we unpack it into what's called an intent, which is essentially what was mapped on the speech recognition and NLU model on the Alexa side. We won't really get into that too much. And be able to say like, oh, we got the shoot intent. Send it on all SignalR clients to tell them all that we got a shoot intent, because it was just working for me at this point. And then on the client side, what I would do is when I activated my app for the first time in a UWP or a WPF or a WinForms, we tried them all, I'll get into that. We connect to the same SignalR hub, and basically whenever we get one of those intents, we do the thing. So like pressing 0 for armor, because that's what I custom mapped it to in Call of Duty's Warzone. And then start the connection. Okay, I say Alexa, tell the Warzone controller to shoot, right? I would expect it to now go boop, 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 hit the mouse button or hit a key, but nothing actually happened, which was really frustrating because I spent like 3 days working on this. I was like, I know what I'm gonna do. I'm seeing the request come to the Windows app, I'm debugging it and everything's working, but nothing happens in the game. I can even go into the notepad, have the same app run and be like, oh, I see the buttons actually being pressed. I see the key inputs being typed into notepad. It should work in game. So I was like, all right, maybe it's a thing with Call of Duty. Actually, no, I'm gonna go back. I had a different scare with this. For those of you who use Visual Studio, little piece of advice, don't try to debug, don't start the debugger if you're running any Call of Duty game. It will crash both at the same time. And I was sitting there panicking, I was like, oh my God, did I just get banned? Like, did they think I was cheating? I was using some sort of like input macros or something like that. And then I ended up like, calling some of my friends at Visual Studio, on the Visual Studio team and at Activision being like, did I get banned? Like, I broke Visual Studio, it's not opening anymore, and I can't play the game anymore. And they're like, no, your account's fine. No, Visual Studio is fine. Just like try running it without the game. So yeah, reproducible thing. Run a debugger, run Call of Duty, bop, closed. Okay, Call of Duty wasn't working. What about the other games? Can I go play Dark Souls again? Try to say, Alexa, tell the Dark Souls controller to roll and have it roll. That was the goal. It didn't work. Went to the next From Software game. This is a stupid choice because it's the same engine. Nothing there. Someone in my Twitch chat when I was building this recommended this game called Crunker. I had never heard of it. It's basically like a Roblox knockoff, but it runs in the browser because we were sitting there in the browser and seeing the key inputs working. That worked. I actually could say jump and it hit the spacebar and my little guy went up. Some other things that other people brought up along the way that I tried as well that didn't work, using a WPF app instead of UWP and using the send keys command, using WinForms and send keys, using an extended background task that was constantly polling and waiting for key inputs asynchronously, and I even tried doing a USB over IP. Nothing happened in those games unless it was running in the browser. And then I got introduced to this little guy, the Arduino Leonardo. Has anyone done any Arduino development before? Nice. If you haven't used the Leonardo specifically, there's a unique aspect to it, which is it is the first of the Arduino devices. The Micro is the same thing now. Basically any of the green ones versus the blue ones that can do true USB and serial in. Typically, there's sort of an extra chip that does like serial to USB, and it's kind of hacky. It's what they did in the past. But what that really means is that I can send information from my PC to the Arduino and also have it send real USB input back. So I could plug it in, and it would tell my computer I'm a keyboard and I'm a mouse. So I can now change my little diagram here, and instead of using like a send keys or something like that from WPF, I would make a serial request to the Arduino Leonardo that was plugged in, and it would send a USB input back. And we got that working. Here's our first video of it working in action, including a little Twitch bot where people
kind of like predict where they're gonna head into.
Pre-warning. There's
Alexa, tell Warzone controller to shoot.
Oh.
Okay, chat, we need you guys to get one headshot. That way we can at least get the highlight. So someone's got to start shooting. Take a shot. Take a shot. There it is. Oh!
If you don't see it, let me see if I can kind of highlight it here a little bit. Oh. Zoom. We're not zooming. There's a little tiny exclamation point shoot that someone typed in chat, and that's what actually shot it before I got run over. So, okay, maybe there's something there. So what I wanted to do now, I had a working prototype, kind of. It was slow. If you heard me say, Alexa, tell Warzone controller to shoot, first of all, that's a sentence and a half to say. Second, it was like, okay, yeah, you're good. Okay, a few seconds. So now let's go and confirm it and go from a working software prototype to something that can actually be usable. I first wanted to look at other things that were out there for accessibility tools and assistive devices in gaming. The first thing I came across was the Xbox adaptive controller. This thing is amazing. It's essentially, it acts like a real Xbox controller, but rather than having joysticks and buttons and triggers, it has these little inputs. You can bring your own buttons. You can use ones that are built by other manufacturers. Logitech makes a few. I think Samsung just released a couple. So you can have like buttons that are completely custom set up in order to act as inputs. Take, for example, this one in the top left where he's got the yellow button on his headrest, meaning that he can hit his head to the left, and that would be the same as me using a controller with my hands to hit the Y button. Custom joysticks, buttons on a pad, and everything else, and it allowed you to adapt the controller to the way that you wanted to play. It was amazing. There's other tools in gaming specifically as well. If you're using Xbox, you can use Cortana for voice commands, help you sort of open a game real quick. You don't have to go through menu navigation. There's co-gaming, which is basically two people with two different controllers acting and controlling the same person. There's skill-based matchmaking in online gaming, meaning if you're not as good because of a disability specifically, you're not going to get put into the same lobby with pros who are going to roll over you. And in a lot of first-person shooters and as well as role-playing games, there's also game difficulty settings. You can turn it down to easy mode. You don't have to play on the hardest difficulty. But Dark Souls doesn't have that, and we'll get back to that. There's a lot of groups out there doing amazing work in this space. Able Gamers Charity is one that I work with. They do some awesome work with, they're also the co-inventors of the Xbox adaptive controller, but they also will go and help people set up their devices to work best for them. They'll meet them at the hospital if you just had a spinal injury, if you have cerebral palsy. They'll be able to go help you get your configuration working for you. There's people like Special Effect out of the UK, same sort of idea. Warfighter Engage, which works with injured veterans from war, and then the Cerebral Palsy Foundation, obviously working specifically with people with CP. So, okay, there's something there. There's a gap still because those people, even with those devices, cannot keep the same pace as someone like me being able to claw my hand on a controller or being able to use a keyboard and mouse. There's still a gap. And so what I wanted to do next is actually scale that prototype. And we start with those key components minus the device because, it's kind of obvious it's the requirement. We need to be able to support more than just me, right? If you remember from the SignalR thing, I was like, SignalR clients.all, just send it. If anyone's connected, receive the command. We want to be able to support more devices, more voice assistants, more desktop clients, more desktop client types, so Windows apps, Mac apps, everything else, and obviously support more games more easily. So to support more platforms on the voice side, I use Voicify, sort of be the connecting tissue of all of those different assistants. For the app side, both on the desktop and a mobile app to control it, I use Xamarin, now Maui, if you're in the RC phase of that. And then to handle more users, I had to implement different authentication and user management. So we had to introduce authentication walls on both sides of the API. So anything that was coming from a voice assistant, I need to know it's you, and I need to know that it's you on the other end receiving it. So doing it from the desktop side, especially with Xamarin, there's tools in Xamarin Essential that make this quite easy. You can do things like use the Xamarin Essentials Web Authenticator with OAuth 2 as long as your server is built to the OAuth 2 spec, and it basically handles it for you. On the voice assistant side, it's disgusting. You have to basically create and register all of your OAuth information on Alexa or Google. They're all basically the same. You then have to send a response to say, hey, please tell the user to authenticate. They now have to leave the smart speaker, go to their phone, click the button that says account link, sign in, then go back, and then go back to the speaker, and then try again, and then you start getting the access token, and it's all sort of handled. But it's a lot of back and forth that sort of happen automatically, and it's kind of a pain for the user. But once you're done, you're good. And so what that looks like now is on the .NET side, just setting up bearer authentication, or authorization rather, to be able to take the token from either side. So I can get the token from Alexa or Google, or I could get the token from the app, or I guess I need both, in order to make sure you're the same person. Then this is using that Xamarin Essentials Web Authenticator. I hit my endpoint. I call sign in with my client ID and my client secret to get tokens back, some state, some information, and the redirect URL to come back to the app when it's done. And we're good to go. I can now sign in on a desktop app, and I can sign in on the Alexa speaker, and it knows that it's me in both places. So now we need to handle more games. We need to customize and personalize. I've made a little desktop app where you can go and select any key in the keyboard and say, if I say jump, hit the space bar. If I say forward, hold the W key. We also wanted to add more usability features like macros, being able to run multiple inputs in a chain from a single command. So this is, for example, in Sekiro, I can say double jump, it'll hit the space bar twice. You can make that chain as long as you want and run a whole bunch of different things. I also wanted to introduce action queuing, the ability to say jump, 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 especially when you're in a panic, and have that actually do 3 jumps or try to basically queue them up, even though it's still waiting for your voice to handle the process. So this is what it looks like to actually receive the key press on the Windows app side and then send it to that serial device. We create a data writer object, we connect to our serial device, and we send it essentially a string. If you're not familiar with serial, that's kind of how it works in general. You send it a whole string, and everything you sort of define as your end of a statement, and you define what your sort of commands separators are. So in this case, the space character separates the command, and new line says that's the end of the command, which means that I would send it over this data writer, press space 500. Now when I receive that on the actual Arduino, so this is now a little Arduino sample, I would run the press key command because we got that press. So from the press space 500, first thing is press, cool. Now we've got space 500, what do we do with that? We go and pull out all the arguments. We say, okay, we got the key that we need to hit, that's the space bar, so let's hit space on the keyboard, and let's hold it for 500 milliseconds. So you can run a whole bunch of different commands. You can say, press, 1, 2, 3, each one back to back in like 50 milliseconds, like 1, 2, 3, just as if you typed out 123. Pretty cool. So now I wanted to prove that this whole thing can actually work together. My favorite thing to do with projects like this is submit them for hackathons. Anyone done a hackathon, a dev post hackathon or anything like that, been competitive with your development? It's a ton of fun, a great way to earn some cash or other cool prizes too. I submitted it during the Microsoft Azure hackathon for accessibility and the Azure AI hackathon, which we got second place in both. And essentially what I did from there is added the use of cognitive services and bot service rather than using Voicify for everything, which means I could use the microphone to that same desktop app and keep it all in a loop to make sure that we don't have to go use an Alexa speaker. So rather than having to say, Alexa, tell Warzone controller to shoot, I can just say, shoot. And here's a quick example of that running in Sekiro. It's still slow, which you'll see, but this is a great sort of example of it end to end as well.
All right, hopefully it continues on the one we just did and not our new game +4. Attack.
Oh, that's super dark.
There we go. Oof.
You just narrate if there's a bad guy there. He's trying.
Block. Ooh, attack. Attack.
Thanks.
Ooh, that was actually done in time. Attack. Attack. Attack.
That was like a cool 3-second delay. Also, this is probably my favorite little hackathon project I've ever done. I called it Snap Keys, and it was for SnapKit, which is Snapchat's developer tools for building custom lenses. But you might be thinking, how did you incorporate Snapchat into this? And essentially, it looks like this. You use the Snapchat app, and we added a custom lens that can recognize different hand expressions and face expressions. If you haven't used Snapchat before, they have built-in triggers like if you open your mouth, stick out the dog tongue, right, for their basic filter. I was like, well, what if I could like open my mouth and have it shoot in Call of Duty, or show like bullhorns and have it do a jump dive in Fall Guys, which I know I'm sort of dating myself as a gamer now. This is a few years ago. So in order to do that, I made a Windows app that could read my desktop screen, just like we did originally with recognizing things happening in game, but instead it was picking up QR codes from the streamed phone that was running Snapchat, and then it ran the commands. It ended up being really fast, and I've got a quick demo here of using that plus voice commands in Fall Guys. And of course, we were using Snapchat, so we had to use a whole bunch of different video filters. So left side is the actual app. That's Snapchat. Right side is Anime Alex in the corner.
It says that I think it did it too fast, and we basically like crashed the game. Oh no. I think that would type in M, by the way, which I don't know if it's wired to anything. We'll see. Okay.
Using the QR codes flashing left and right for different hand or face movements. Every time I smiled, every time I raised my eyebrows, every time I opened my mouth, I was going to flash a QR
Every time I take it, I'm going to have to like keep my coffee down here so I don't have to use my hands. So I'll be like... Alright, this is a good one. I gotta like... I'm going to end up like doing like this and like punching my coffee. Alright, we're playing one-handed. So I'm going to keep my other hand here so I can just be like, real quick. Just to see if it's working, I'm going to use my eyebrows. Little jump. Little fist. Jump. There's the jump dive. Alright, we're off and running.
I cut the video short because it's basically 50 minutes.
Double jump. Please.
And yes, I lost very quickly after that first level, but it was still pretty cool. I was able to use my mouth and my eyebrows and stuff like that to play my game too. The last thing I did for prototyping was Twitch keys, which you've seen in some of the previous examples where the chat is trying to type stuff in, and that's also executing it because it's just another connection into the API. So here's another example in Call of Duty. It's a little small, but in the bottom right, you can see a bunch of people saying exclamation point, press shoot or press jump or something like that, and it'll happen right away. So keep an eye on the bottom right where there's the little feed going up and down.
Someone give me a no scope. How's the delay on chat now? Mouth open, reload. Jump. Just a little. Come on. Oh, here we go.
Ooh, great time to pause it. Okay, so there's really something there. With the face and the voice and third parties, it started to come together. It got a little bit faster, and I wanted to take this to production and actually give it to people. So I created Enabled Play. And essentially, there was a couple key pieces left in terms of going from these prototype applications to something that's truly production ready. Performance was trash. You guys saw it in the Sekiro example, and I was like, attack. Boom, okay, that's not usable in games. Privacy, I was streaming your audio to Azure or to Wit if I was doing like Facebook or to Google's speech to text. Which means that your constant audio while you're sitting there playing your game is being handed to a third party. Now, their privacy policies obviously mean they're not recording it and using it and identifying you with it, but what you're saying is being sent somewhere else. Same thing with your video. I mean, you're using Snapchat, you're streaming your video to Snapchat servers. And now, because I was using something like cognitive services, that gets really expensive. You're talking about just me sitting there with my face on camera and using the speech recognition all being streamed to Azure. Just me playing for like 4 hours. It costs a few bucks. You scale that to 10,000 people playing for longer times. We're talking about 5- and 6-figure monthly bills to be able to run this thing. It's not reasonable. And the last thing was continued scale. The app didn't look good. It was gross. And I wanted to be able to do more against different games, add more features. So we need to make it faster. We need to make it more private. We need to make it cheaper. And we need to be able to scale it even more. So the first thing I focused on was speech recognition. You know, I've done speech recognition before. This is what I do in my day job. But this is what a sort of traditional speech recognition approach looks like. We detect that we need to start recording the audio. That might be pressing the button. That might just be when the app starts. Start recording the audio. We're then listening for the audio recording. We detect that they've stopped speaking, usually by volume, right? So, okay, you've stopped at the end of your sentence. You got like maybe 100 to 500 milliseconds to say, okay, you're done. We send that whole audio chunk to some other service to process the speech. What I wanted to focus on instead was something more predictive in real time or automatic. And so what essentially that means is that it's always on. We're always recording, but rather than waiting for you to stop speaking and then sending the chunk up, we're sending everything through the processor, which is running on the device itself. I don't have to stream that to someone else. It's entirely offline, rather than having to run it from Azure, then back down to a Windows device, which then is sending to Arduino. I'm running everything on a Raspberry Pi, which has enough compute to be able to support a speech and image recognition model at the same time. It also means I don't have to pay anyone. I'm not streaming anything to Azure. You buy a Raspberry Pi and you can run this offline and start speaking to it right away, which is pretty cool, with a microphone anyway. The performance is insane. So that jump, jump, jump example I gave you with the action queuing that we had before, where we have to record all 3 jumps. Okay, you finished speaking. Now let's send it up. Okay, we got the 3 strings of jump. Now we know that we need to jump and hit the space bar 3 times. The fastest I ever got that, ever, was 1.5 seconds from start of speech, jump, 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 that first J sound, to actually executing in game. 1.5 seconds was the fastest. The average is like 5 seconds. With predictive ASR, I know the second you're saying jump before you've even finished pronunciating the P sound at the end of the first jump, which means I can execute all 3 within 30 milliseconds if you can send it fast enough. And again, all offline. On the privacy side, I already sort of talked through this, but one, we don't have to pay for cognitive services, and your audio does not go to cognitive services. And it's basically the same thing for online expression detection. Same sort of concept, right? If we're going to detect your eyebrows raised, detect your mouth open, and do something, we need to send that to a server. We need to record your video, and then every single frame that we want to process, we got to go upload to Azure, or upload to Google, or upload to AWS, or some sort of image recognition service that's going to say, the chance of your mouth being open predicted is like 90%. Okay, that's good enough for me. We'll call that a mouth open and run the command. Great. Now that's, first of all, slow. If we're going to run that on every frame against like a 60 frames per second camera feed, there's no way. And it also, again, is super expensive. So what we did is the same exact approach. We took it offline. We ran it either on your phone or on the device itself if you've got a camera plugged into it. But you can also use the app, and it'll run offline on the app, which means that we can process each frame. We don't have to wait for an upload of a video. We can detect your different expression changes, your body movements, your hand gestures, and everything else, and also turn those into commands. So with all these things together and a couple other things that I'll show in a demo, this is what it now looks like. So no longer dependent on a different voice assistant service like Alexa or Google to be able to do it, no longer dependent on cognitive services to be able to process it. And so we've got a single ASP.NET Core 6 API running an Azure App Service that's used to be able to facilitate things like authentication, to be able to facilitate requests coming to it from third parties that can also authenticate the user with OAuth, and then to be able to send those commands directly to the device itself over SignalR. So the device is connected to the internet. You use the app to be able to set up the Wi-Fi, just like you would any other IoT device. And now we're sending it directly to it. Now you can also do it offline if you're using the app. You can send commands from the app over Bluetooth. It's a little bit ishier. You got to be right next to the device sometimes for having enough confidence. But get it connected to the internet, and you're good to go. So now this is sort of what it looks like to be able to trigger the start of listening on the device itself, rather than taking the audio from Alexa, grabbing an intent, and then processing it. Instead, we have an ASP.NET Core controller and a single endpoint that says, take this device and tell it to start listening. We validate that it's your device, and then we send the request to the device using the SignalR client's user with a specific ID, and we say, hey, receive the start listening command. And then we execute that from the app. Again, it's still Xamarin, it's all .NET, to be able to just make the post request and say, hey, this user device ID, the one that I'm currently using, please tell it to start listening. Now, the app itself on the firmware is running Python. We still connect to SignalR, and we basically say, when we have start listening, tell the voice service that's going to be processing our model to actually open up the microphone and start listening and start executing commands. We then have the device basically send the status back, like, hey, I am listening now. I need to actually tell the app so it can tell me to stop listening and stuff like that, which is great. It's super fast. It's responsive because SignalR is super fast, and it scales really quickly over Azure. So here's a quick example of this in Minecraft with both voice commands and face expressions using macros all offline. It's pretty quick, but you'll see what sort of goes on. I've got eyebrow raise commands to change the time of day to run a macro where it's typing in the Minecraft console. I've got voice commands to run, and I've got macros to be able to actually automatically build structures using a single command, which is pretty cool.
Go. Three by three.
That's it. Quick little Minecraft sample. Here's how the setup actually works for that. You sign into the Enable Play app. You create profiles for every game or every program or however you want to categorize it, right? It's where you basically pack in your commands into the actual actions that should happen. When I say create three by three, hit the left or right click to place it, then move back using the S key, then turn with the mouse and hit right click again, and it all runs very quickly. But I'm doing that by just creating a macro. Now, you don't have to use this for gaming either. We can do this for any sort of application. I use it all the time in my actual building process. Pretty meta. It's cool. But to be able to actually compile it, deploy it, all with a few single commands. You then basically select the thing. So if it's a face expression, you do that. There's tilt controls in the app as well, so you can attach your phone to some sort of arm, especially for people in wheelchairs. It's super great to be able to like use their phone like angle as like a mouse cursor without having to worry about a touchpad or an actual swiping of an arm, just tilting their phone, or to be able to trigger commands that way. And so for example here, I've got if I tilt my head right, if I turn my device right, or I say right, hit the right key. Then you go into your device's page and you send it commands. You tell it to start and stop listening like we saw. You can use those tilt controls. You tilt your phone past a certain threshold to trigger commands. You use expression controls directly within the app, tilting your head, smiling, raising your eyebrows, winking, moving up and down, sort of crouch versus rising up, leaning left and right, which is really cool for first-person shooters, like peek around a corner by actually like peeking left and right. It's pretty immersive, super cool. There's also hotkeys. You got buttons that you can use to also trigger any of those commands. There's also remote typing, so you can type from your phone. Typically the software keyboards especially on iPads, are way more useful for people with physical disabilities in their fingers versus a mechanical keyboard. So being able to use either like dictation directly through that or any other way you want to type using a touch screen. You basically type what you want to type on your phone or on your tablet, hit send, it'll type it on your PC or your Mac. And all this comes together to make some really great experiences. So Minecraft is simple, right? You could play that without having to be quick or responsive. But I wanted to go back to that Dark Souls example, that fast-paced, hard, competitive. How do we make this something that someone can play if they don't have the ability to react and claw hand over a controller? So what I wanted to do is actually do the sort of latest installment from Software, which is Elden Ring. Has anyone played Elden Ring yet? Anyone? Anyone heard of Elden Ring? Latest game, yeah. There's a lot of talk about accessibility issues with it. It's more accessible than Dark Souls because you can run away, but if you don't know, it's an open world fantasy RPG. The same sort of approach with Dark Souls. Super hard bosses, very punishing, but it rewards patience, it rewards repetition, and it rewards your reaction time. But it still has that same issue of, can I actually hit 10 buttons in like 50 milliseconds with my tiny controller? And if you can't really play the game. So what I wanted to do is put together a quick example. This is like a 4-minute video of a few different things. Again, voice and face expressions in this use case. And I'm using only joysticks underneath. You won't see them in the camera frame, but everything that's not movement of a joystick is all done with my face and voice. We're able to do some practicing with parrying, and we're also able to beat a boss this way.
Attack. Dodge. Block. Mount. Run. Heavy. Heal. Heavy. Left heavy. Dismount. Enter. Heavy. 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 Dodge. Dodge. Heal. 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 Dodge. Heavy. Heavy. Heal. Heavy. Heavy. Dodge. Heavy. Heavy. Attack. Heavy. Heavy. No. Heal. Heal. I'm gonna smell it, don't Jump. 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 Sneak.
There you go, least accessible game. I beat it with my face. So, you know, I set out to make specifically Dark Souls originally more accessible. In the end, it's great to see Elden Ring actually playable in such ways. And of course, like, that's used by me, which is not the target audience, but you know, the people that are using these devices now are doing the same things and making it work alongside their existing tech, like the Xbox Adaptive Controller, to play games in new ways. One of the things that sort of stuck with me was this quote from one of my mentors, which is, sometimes you set out to solve a specific problem, and along the way find your solution solves way more than you imagine. And that's exactly what happened for me with this. I wanted to make gaming more accessible. I wanted to make Dark Souls and Elden Ring things that my brother could play with his disabilities and other people like him. And what I was introduced to is the fact that this issue of accessibility in terms of the human-computer interaction does not stop at games. It actually exists basically everywhere else, including in our own world as developers. Being able to write code as quickly, if you have the inability to use your hands or even just type as fast as others, you are naturally now at a disadvantage. Right? If I can type faster than you and we know the same solution to the same problem, I'm going to win. I'm going to be able to build it faster than you can. And there's other tools out there that make this incredibly easier for those of us that are developers to do these things faster and faster and faster, but a lot of times they're also not as accessible. And so what I wanted to show you all was a hint and a little demo, live, if everything's going to work in my favor, of being able to code hands-free. Write in VS Code using the device here, which I have on the desk, and be able to do that with Copilot, which is another great accessibility tool, although many of us are worried about it eventually replacing our jobs. It's a great sort of tool to be able to make software development something that anyone can do. So let's get into that. And let's see. Open code. Comment. Type, write a loop from 0 to 100. Enter. Function. Tab. Tab. Enter. Comment. Type, add a button to the page, and when it's clicked, run the loop function. Enter. Tab. Tab. Enter. Comment. Type, run the add button function. Enter. Tab. Tab. Please. There we go. Look at this little program. We're looping from 1 to 100. We put a button on a little HTML page and some JavaScript, and we ran it from the beginning. And I'm sitting here with my arms crossed, which is pretty cool. But the same concept, you know, with the face expression and recognition, gesture expressions, things like that can also work. If I want to be able to move my cursor left and right, I could pull up my phone camera, turn my head, tilt my head, or I guess the opposite, right? Turn, tilt. If I wanted to build, I could make that into a macro where it can open up the console and build it for me with just the expression or voice command. And not just through development, but basically through any computer interaction to be able to make this something that others can use. And so now Enable Play is not just being used by developers, not just being used by gamers, it's being used by developers as well, but it's also being used in computer science education programs, usually at like the high school level, where students are developing against that third-party API. Their fellow students are using the devices to be able to actually do computer science and use the computer labs that they weren't even allowed to use before. And it's become something that's been pretty amazing to see, being able to watch students develop other tools for their fellow students. And I want to be able to now extend that to other developers as well. There's an early access program that I've started to be able to get access to the developer APIs. You can learn more at enabledplay.com. And then lastly, everything from the prototypes is entirely open source. Eventually, these will be open source once I get a few things sort of roughed out for the rest of it. Everything else, all the other videos and demos and things like that, were all filmed live on Twitch. So you can follow me on Twitch. I don't stream very often anymore, but when it comes to developing new features for it, I'll usually do it on there. And if you want to learn, again, more about Enabled Play and the new controllers and everything else, you can do that by heading to the website. If you know someone that this could benefit, that could benefit from not just gaming, but from being able to actually use their computers or game consoles in new ways, come find me, come let me know. I've got programs set up to be able to get these devices out to people that need them. Or if you want to have an immersive gaming experience and be able to lean left and right and say shoot alongside using your controller, you can grab a device yourself as well. And that's it. Any questions, anything like that? Cool. Thanks, everyone. You can always come find me after. And make sure you come to the after show. We're going to be doing some cool comedy stuff and of course, playing the Line Breakers hits as well. So I'll see you at the rest of the conference and enjoy the rest of your day.